Okay, so as I was saying, recording for our class today, average speed is how far an object travels in a given time interval, distance traveled per time. If I wrote that with letters, I would use a capital letter S with a bar over top. That means average speed. And then I would use, instead of distance traveled, I'd just write that as D. And then instead of time elapsed, I'd just write that as T. That'd be one of our equations. And if you look at your equation list on the inside cover of your packet, you'll see that equation. Speed is distance over time. I want to show you how to use it. Now, velocity is not the same as speed. And I want to take a moment and just talk about what velocity is. I'm sure you've heard of this maybe before. Maybe, raise your hand. You've heard of velocity? A few people? All right. Velocity includes the direction. So it's not just how fast you're going, it's which way you're going. That is a key thing here in physics, is that velocity includes the direction. So which way is it moving? So in one case, it was going towards Molly, sort of towards your guys' your right. And then the other case is moving towards Biswas, the other way. That velocity has changed, even though the speed is the same. So the directional change includes, that would be a velocity thing. Now, you guys are familiar with miles per hour, right? And if you think about miles per hour, miles is a distance. And H is a time, right? So hours is time. So all I'm doing is I'm dividing those two things. We don't use miles per hour in our class because it's not one of those metric units. Over in Canada, over in England and stuff like that, they use kilometers per hour. That's more of a metric. We use the meter per second. So the unit that we use in our class is the meter per second for speed. The table on the right, you guys are familiar with these values. If you drive, you know what 11 miles per hour feels like. You know what 45 feels like, 67. You might even know what 89. Nowadays, the speed limit's up to 75, some places 80. You might see that. And cars will sometimes go a little bit over the speed limit. I hope you don't know in a car what 112 miles per hour feels like, but I imagine some of you might. If you've been in an airplane, you're probably traveling 500-600 miles per hour, so you know what those speeds are like. This is the unit that we will use, is these. So what this table is here for is to give you a sense of comparison. And then over here, your speedometers often have kilometers per hour as well. I want to see if you can do this. Can you look for a pattern? Can you identify what goes in those two blanks? This would be sort of like a mathematical reasoning thing. Can you figure out what goes in those things based on pattern recognition? Yeah, so some of you are going to be really good at this. Others are going to be, I'm not sure where the number is coming from. How'd you get 22, Liam?
It was 5 meters a second is 11 miles an hour, so double that.
Wonderful. This is what we call proportional reasoning, right? So that idea is if the 5 turns to 10, then the 11 would turn to 22. It's just proportional reasoning. How about the other one, the one on the far right? I would look for easy conversions. I look at this and I say, that's 5 and this is 50. How many times bigger is that? That's 10 times bigger. So therefore, if this is just a conversion, 18 kilometers per hour must be 180 kilometers per hour. All it is just scaling things up. Matter of fact, that M&M activity that I gave you guys on day 1 was really just about scaling things up. If you know the mass of 1 M&M, you might be able to scale it up to 150 M&Ms, right? Just by using proportional reasoning. It's that idea. Now, I'm going to try to convince you that the speed limit sign should be replaced with velocity limit signs. I want to talk a little bit about direction. So I'm going to share a story with you, and I do a lot of story sharing in part because there's a lot of interesting physics involved in this, and I've lived a fairly long life so far. So I'm going to share this story with you. Driving down south, this was about 10 years ago, down south, going on a Christmas or a vacation to Florida, driving my family. I'm going down I-75 south. I'm going through Tennessee area. Raise your hand if you've ever been in that neck of the woods. Okay. So I'm driving down there, 75 miles per hour south on I-75. I've seen this in the movies before, but in real life, it's scary. Another car, this 2-lane highway, divided, right? So 2 lanes going south. The other 2 lanes going north are over there, divided by 100 yards of dirt and stuff like that, right? I'm going south on I-75. And sure enough, on a 2-lane highway, another car is going this way and the next lane going that way. I'm going about 80 miles per hour. And when that car rips past going this way at 80 miles per hour in your side of the highway, you freak out. And I mean, I'm like, did you just see that turn? Did you just see that? Because she was reading a book or something like that. And I'm like, have you ever had that happen to you? It is scary beyond belief. That car technically was not breaking the speed limit. Well, maybe they were going a little over. But were they breaking the velocity limit? Were they going the wrong way? Absolutely. So the velocity includes a direction. I think our signs out there should say velocity limit, 55 meters per second north. It'd be safer that way, right? Because we're all going to be traveling in the right direction, or south. Raise your hand, you've ever done any driving in a city where there's one-way streets? The one-way streets, that's a directional kind of motion, right? You need to make sure you're going in the same direction. So velocity is more restrictive than speed. I want to see if you can apply that to this here. I'm going to take this ball that was whirling around, and I didn't do this demonstration the other day. I just showed you a video of it. I'm going to try it right now. Dawson, if I throw this, I'm going to try to throw this towards you and Seppi, and sometimes probably this goes wrong. Brent, I'm sorry if this goes wrong. I'm going to try to throw this to you. Okay, I'm going to just try to throw it. So I don't know who it's going to go to, but I'm going to try it. Constant speed. This is about 10 miles per hour. It's a constant speed. If I put a speedometer on it, it'd read 10, it'd read 10, it'd read 10. 10 miles per hour. Is it a constant velocity? No, why not? Because its direction is constantly changing. So velocity includes a direction. I'm going to release this thing, so I'm going to try to throw it to one of you too. Where should I release it to get it to these two? Where should it be? Over here. It should be pointed sort of towards Odin, right? So that when I release it, it travels in a straight line in the path that it was traveling. Are you guys ready? Watch yourself just in case, because it has gone wrong. So we're going to release it right about there, and sure enough, once it left my hand, right back to Dawson. You want to throw it back to me that way? Or you can do it like that too. It's an idea. Now, it might be easier. Would it be easier for me to do it like this, to be able to get it to you? Absolutely. Let's just try it. Are you ready? Right between you. I was a pitcher in high school, so I'm pretty good at this. Are you ready? And so, yeah, so the problem with that is I released it a little too late, right? I should have released it now. All right. Constant speed, variable velocity. Guys, I'm sorry. I have to have a little bit of fun. Constant speed, changing velocity. And that's going to come into play a lot. Yesterday, when we were kicking that bowling ball around, most of us were kicking that ball around as traveling about 1 meter per second. But to change the motion of that ball, you had to kick it, didn't you? You had to exert a force to change, not its speed. You had to exert a force to change its velocity. The velocity of that ball was pointed that way, and then all of a sudden it's pointed this way. That requires forces to do it. So velocity includes a direction. Such a key thing. Now, folks, I know that people are going to struggle with math. I know. This is the bare minimum that I can go through with you. Let me tell you right now, this is going to go on record, on the video. You will not be assessed on quizzes or exams with math. You're going to see very little of that. You're not going to see this on a quiz or exam. Where are you going to see it? On the project. So the expectation is that you can take what we're learning here and figure out how to do the mathematics, and where it's going to count is when you do the project. So when you go to do your egg drop project and you're like, I want to determine the impact force, I want you to know how to calculate the speed. I want you to know how to do things like the forces that are involved. So where the calculations are going to come into play, we feel most comfortable, let's make those be on the higher end projects where you have adequate time, adequate resources to figure it out. Does that make sense? If this were a math class, I'd be like, all right, you're going to be able to do this math. The math is supporting the physics, right? It's not the central idea. It's not the math. We're using that math to support the physics. That's the goal. All right. Let me show you a couple of things here, and this is about as minimum as I can make it. Speed is distance over time. Distance could be written as speed times time. All I'm doing is I'm rearranging that equation so that now its distance is equal to something, And then this one over here, time would be distance over speed. It's really the same equation, just written for a different variable.
But what's the middle one?
Distance would be speed times time. So what you'll see on your equation list is you'll see an equation like that. It's how we define speed. You would then need to rearrange that thing and look for a different variable if I'm asking you to determine the distance that something travels or the time it takes to travel. I'm going to go through 3 examples with you. Okay? Just do your best. Try your best on it. I'd like to see, I know I have some people that run track in here. Track? Okay. Would you mind sharing, Lauren? What do you run? 102, and those are sprints. Anyone do a 400 or 800 or 16? What do you run?
400.
Okay. So the 400 oftentimes, what's the other one? The 4x8, okay. The 400 is often thought of as like one of the most challenging races. And the reason for it is it's not quite a sprint and it's not quite a long distance run. It's more sort of in between. And if you go all out, you're likely going to sort of really struggle in the last 100 yards or so, right? So I've had plenty of kids in my classes and I'm like, if they can run a 53.2 second 400, is that pretty good? That's a pretty good time. Let me show you the average speed during that race. I'll just show you how to do it. I would write that down as speed is distance over time. I would take that 400 meters. I would divide that by the 53.2 seconds. And that would give me, I can't do this math in my head, but I just did this last hour. So I remember that number to be 7.52 meters per second. All I'm doing is, I don't have to use a calculator for this. But that's what I get, 7.52 meters every second. This room is almost it's a little bit more than 7 meters long. It's almost about 8 meters long. What that means is that person in this race would cover this distance about every second, which is moving. That's a pretty good speed. Could you tell me what that is in miles per hour about? Go back to the previous page. What is that about in miles per hour? See if you can do it. This is what we call proportional reasoning. About what? How'd you get it? I can't help you. So would you guys agree 7.5 is about halfway between 5 and 10? So if 5 was 11 and 10 was 22, we'd be halfway between those. Agreed? It'd be about 16 miles per hour. So that person's running on average about 16 miles per hour. Do you see how I did that proportional reasoning? Do you see that? Yeah, so all I'm doing is I'm just sort of going halfway in between those. It's okay. That's a pretty good time. Now what I want to do is I want to figure out, that's a pretty good speed. What I'd like to do is figure out how long it would take if that person could run the mile at that speed. How long would that take? Now, I'm solving for a different thing here. Number 2 is saying, I'd like to know how long it would take to complete a mile. So this one is, I'm going to use this equation. I'm going to use time is a distance that they're traveling divided by a speed. It's the same equation solved for a different thing. They're going to travel 1,609 meters, and they're traveling that at this rate. We're assuming that they can keep that up the entire race. Very likely going to have a hard time with that. Now, Lauren, you also do cross country, don't you? Typical mile pace, like for cross country?
Top guys, it's like 5 something, 4 something if you're really good.
Yeah, exactly. Okay, so it's tough to run long distance. Your body has to go through a different kind of mode than a sprint, right? Sprints are different than, it's called slow twitch versus fast twitch muscles. I don't know if you're familiar with that kind of stuff, but slow twitch is more for the endurance stuff, and then the fast twitch is more of the sprinting stuff, right? So it's how quickly the muscles sort of move. This would be 214 seconds. I'm going to write that as 180 seconds and 34 seconds. And you might wonder why I'm writing it like that. No one knows what 214 is, but you know what 3 minutes 34 seconds is, right? Mixed units make it a little bit easier to understand. This would be 3 minutes and 34 seconds. Ian, give us a sense. What could this person be doing with their life if they could run that? Yeah, they would probably have some gold medals around their neck. That'd be an Olympian world class kind of sprint, right? Or kind of speed. There's no way that they're going to be able to do that without super training. Last question. A car maintains an average speed of 35 miles per hour for a road trip. Your speed is constantly changing on a road trip. Sometimes you're traveling really fast, sometimes you're stopped. Let's get an average speed of 35 miles per hour. What would be the distance of that road trip if it took them 2 hours and 25 minutes to do that course? Okay, so I'm going to again show you how you would use these equations. This one's asking for how far. That's a distance value. Distance is this. This is a time value. So what I'm going to do is I'm going to go ahead and solve this for distance. Distance would be speed times time. The speed is 35 miles per hour, sometimes 70, sometimes 10, but the average is 35. Okay, I'm going to write that as a rate, miles per hour. I have to multiply that speed by a time in what unit? What must be the unit for me to get miles out of this equation? It's got to be hours. So what I have is I have mixed units up here. That 2 hours, 25 minutes has to be written as so many hours. I can't write it as mixed units. I have to make sure the units are just hours. Can you convert the 2 hours, 25 minutes into a number of hours with a decimal? Can you do it? How I do that is I would say 2 plus 25/60ths. Now the reason for that, I've had plenty of kids say it's 2.25 hours. It's not, because there's not 100 minutes in an hour. There's 60 minutes an hour, so I'd go 2 plus 25/60ths. I'd use a calculator for that. 25/60ths is 0.4167, somewhere in that area. So I'd go 2 plus 24 divided by 60. That number is, 2 plus 25. That number is about 2 plus 25 divided by 60. That number is about 2.41 hours. So I would go through and say 35 miles per hour multiplied by 2.417 hours. And when I multiply those two numbers together, I get about 84.6 miles. And that's how I would do that kind of calculation. Okay? Questions for me on that? Math is a strong suit for very few in this class, right? I know that. That's okay. We want you to do your best on it. I promised you enough time to be able to work through some questions. I normally would try to engage you with more activity things. I apologize. Early release dates are tough. So I'm going to stop the video. I'm going to ask